Hi, Yogesh, and hi, Dawn. You are both muted if you're trying to talk.
No, I'm just waiting for others to join. So yeah, hello. Good morning and good evening. Yeah.
Good afternoon from me. That's fine.
Yeah.
Hi, Mike. Hi, Yogesh.
Hi, everyone.
Hi, Usama.
Hello, everybody.
Hi, Dan. Hi, everybody.
So,
Hi.
who owns the agenda for this? And may I request my 7 minutes? Dan knows what I'm talking about, but not all of you do. So
That's Keith's business for this meeting, I guess.
The agenda or what?
Yeah, you own the agenda.
Yep.
so I'd like to request a 7-minute slot, please.
Okay. Would you like to take it at the top?
I honestly don't mind.
All right. Let's plan on that then. You can just start off, and then we can take it from there.
Sounds good.
It's been a bit, Mike. Congrats on the new position.
Thank you. Well, I have been trying to join these, but they keep being cancelled. So I'm glad to have made one.
So we'll give people just a couple more minutes to join.
And people, if you would like to enter your attendance into the link that I dropped into chat, that's how we kind of keep track of everybody showing up or not.
Simon will be joining in a few minutes. He was in a concurrent meeting.
So sorry, I missed something. So should we write our details in the chat? Or?
Oh, sorry. In our agenda doc, we have an attendees list. So in the chat, Dan dropped the link to our agenda doc, agenda and notes. And we'd like to have people sign in there.
I don't know if I've worn this shirt on camera before, but it's kind of a trippy moire pattern going on.
For who?
It shows up normal on our screen.
Yeah.
Oh, in the thumbnail, it definitely does.
Yeah.
Okay, so for anybody else who has hopped on, please do go to our agenda doc, add your name, and who you are representing the interests of. I think we can probably go ahead and get started though. Mike has joined us and has asked for a few minutes here, so take it away, Mike.
Yeah, so it's a bit cheeky, but I just lost it. Hello?
Yeah, we still have you.
Yeah, so I don't know what happened. That was very confusing. Yeah. So first of all, for those who don't know me, Mike Bursell, I was one of the co-founders of the NLS project. I ran Profi as CEO and founder until we closed that down earlier this year. I'm now executive director of the CCC. And one of the things that we're trying to do is to find out what our members and those associated with us would like us to be doing. Because I'm supposed to be executing something, and knowing what I should be executing would be a useful thing. So we therefore have a survey. And what I'm going to do is I'm going to say, you have 7 minutes right now that I've just stolen from this meeting to complete the survey, if you have not already done so. It doesn't matter if someone else from your company has already filled out the survey. In fact, if you're not sure, please copy them and send this to them. But it would be really, really helpful if folks who have not yet done the survey could take 7 minutes now, and I will shut up. You have 7 minutes to complete the survey. So please do that. Thanks, Keith. Sorry.
Yeah, no, completely fair.
See you at 12 minutes past.
We are approaching the end of the allotted 7 minutes. If people are feeling like they're close to the end of the survey, but not yet complete, speak up. We can extend it a little.
Or they can know, oh, well, I don't want to take much time from the thing. They can, do it at the end if that's fine. Or I already have over 10% higher sample rate than I did at the beginning of the meeting. So that's very good news. So please continue at the end of the meeting if you wish to. I don't want to be taking up too much of the time. I really appreciate your time and the opportunity. Thank you, Keith.
Yeah, no problem. Anything else you want to add while you have the floor?
No, just other than I'm here if people have questions and you want to get in touch generally. So please do. I know a number of you, but not all of you. So feel free to get in touch. I'm hoping to be doing more speaking at things and talk to me about things. If you want me to come and see your senior people at your organizations, I plan to be traveling West Coast, Asia Pac, Europe, wherever need to be on occasion. So please let me know. Thank you.
Excellent. Thanks, Mike. And thank you, everybody, for adding your name to the Agenda Doc attendees. I do see some names that I don't remember being introduced before. If anybody is joining for the first time or have joined in the recent past but have not yet introduced themselves, if you wouldn't mind, go ahead and giving a quick introduction.
Okay. Hi. I'm Sampo Savio from Huawei, Finland, and I'm specialized on cryptography and platform security, and that's and I have been involved in many kind of platform security projects and have been participating earlier on a global platform standardization, and actually I'm chairman of the global platform TPS functional APIs working group.
Great. Thank you, Sampo. Do you have anything specific you would like to see in the attestation group here?
Actually, I haven't been so much involved, and I'm just kind of curious to learn more, and I'm personally kind of very interested about the activities what has been done in IETF, like RATS working group and those kind of things.
Okay, great.
Yep. Terve. So some other Finnish speakers.
Anybody else new to the group would like to give an intro?
I'm Vijay Nani, working with Huawei, as like Sampo said before. So I work on the platform security side of the devices, basically here. So my interests are attestation and the low-level security, like secure boot and other things here. So I think I joined after a long gap. Once I was there before, but long before, just interested to see what's happening here again, and looking forward to get involved more in the ongoing activities in the area of attestation, especially. Yeah, thank you very much.
Great. Welcome back. Any others?
Hi, my name is Yash. I'm part of, so I work at Red Hat in the virtualization group. I'm a principal software engineer, and I'm working towards productizing confidential computing in OpenShift and RHEL. I'm actually part of the TAC with Lily Sturman, but this is my first time in the attestation SIG. I'm actually really interested, similar to Sampo, and actually the topic today as well, like a formal specification of the different attestation technologies and how we can converse with them. So I'll be joining more often now.
Perfect. Glad to have you.
Do you have any work already on formal verification? Or any of your group members, maybe?
No, it's mostly been with sort of discussions with other companies, but nothing towards formalizing, which is actually what I hope this SIG would be doing. So it's great to see the very first call I joined is talking about it.
Okay. Right. Thanks.
Anybody else do for an intro? Okay. In that case, the next thing we have is Osama. If you give a status update on the formal verification.
Yeah, sure. So I will share the screen. Just a moment. Okay. I hope you would be seeing the screen now.
Yes, we can see it.
Oh. Okay. All right. Okay, so welcome everybody, and thanks for the interest in this. This is a sub-project of this working group, basically, or the special interest group, which is the formal specification of attestation mechanisms in confidential computing. And for today, I have this agenda that I will give a very brief executive summary of what has been done and what needs to be done in the future, what's the current status, and then briefly about the approach that we have taken in general for all. And in this specific progress update, I will focus mostly on the TDX part, which was one of the goals, and then describe its verification challenges and summarize. Okay, so the executive summary, or the brief in nutshell, the idea is that for inter-TDX, I will demonstrate a simplified model which describes how the evidence is formed, how it is verified at the verifier, and what are the steps that the verifier needs to take. There are still some things to be done. We have it noted down. And then the second goal was for ARM CCA. And I plan that to have that demo in the update of next month. Thirdly, we had AMD, SEB, SNP, and here there is a discussion point with the chairs, basically, that there is some work going on with the University of Zagreb, where Professor Ante Terek is following up this work, and their current status as of yesterday was that he told me that it would take roughly 1 month to complete their formal verification. So it's exactly as we had planned. And to me, it would not make much sense to redo that work. And it's not completely sure that whether they will be willing to share under the Apache 2 license on the CCC SIG. So this is something that needs to be discussed, whether we because there is no novelty. I mean, they will be done in like 1 month with the writing. They have their artifacts, and it's not clear whether they will be willing to share under this license in the CCC repo. So we have to discuss this a little bit, maybe at the end or now, if you like.
Let's defer that to the end.
Okay, sure, right. So then so these were the 3 goals of the formal verification, and we will have an updated draft. We already have 1 draft from the December or January. Then we have done some follow-up verification work, where we have extended inter-TDX specifically. So we will have an updated draft out soon, which will describe in detail how the verification is actually done. And today, as I will demonstrate for TDX specifically. Okay, so, and please feel free to interrupt if you have anything in between to make it more interactive.
And that
sure.
the updated draft, that's the draft of the paper that you were working on with Thomas and Simon?
Yes, exactly, that's right.
Thanks.
Okay, so basically to the SOK draft, we have added in there, we had like, I think only 2 lines for each about the formal verification. Now we will describe it in much more detail in the appendix, probably. So we will have, I think now about half a page, but now we plan to extend that verification part, which will in more detail explain that verification. Okay, so approach, 3 parts for any formal model. We create a model, we have properties, we have threat model that I will describe. So this is pretty much generic thing. I want to go back to this figure, which we had in the beginning, like the architecture lead solutions, where we take ARM CCA as the representative of this group, and vendor solutions, as we call it, which is Intel SGX, TDX, AMD, IBM, and so on. And the boundary between them is the level of customizability, where we can customize many things here, and here the things are less flexible as compared to the architecture lead solutions. So here there is a architecture specification on the basis of which one can build its own solution. So from attestation perspective, it makes sense for us, and also from the verification perspective, it makes sense to have a separate category of these. So one can reutilize, for instance, for the RISC-V verification, one can reutilize some parts here. For AMD, SAV, SNP, we are under discussion with the University of Zagreb how we can cooperate on this or collaborate on this. And they are very interested in this, the follow-up work that we have done for Intel TDX that I will describe. And there are many opportunities that we will have something in collaboration. And here, this is not part of the specific project that was proposed, but I just put it as a reminder that there is another RATLS project where this can be seen as a framework, where we have the remote attestation combined with the TLS protocol, and the composition of both protocols, we basically verify that. So this will provide, for example, for ARM CCA, the attested TLS project, this will provide the foundation for that. We will use the TLS integrated and then verify them together. So this forms basically a framework. So it doesn't describe that explicitly, but here the idea is that for the other project, we will basically use these artifacts of ARM CCA. Okay. Overview of the approach. So we have architecture lead solutions, vendor solutions, and what we basically do is we map them to the RATS architecture. That's the first step, because for Intel, here the Intel TDX, for example, there is no mapping. Intel has given the mapping for device attestation, but not for the attestation mechanism in its own. And here for ARM CCA, we have done the mapping. So I will focus currently on the Intel TDX with some ideas about ARM CCA. Now the idea is that when we have the mapping to the RATS architecture, for example, and we modified it a little bit, and the modifications were purposely minimal. That is what we needed to describe these processes. We only changed the RATS architecture. So that was one of the goals, to follow it as much as possible. So we have the provisioning phase, initialization phase, and attestation protocol phase. And based on combining that, so we have a holistic picture of all these attestation mechanisms combined together for verification, which is input to this formal model. And then the model can be verified, but then we can verify some specific properties for this model under some specific assumptions. It very rapidly goes to the undecidability, so it's not possible without assumptions. So we have to make some simplifying assumptions in order to generate these formal proofs. And so that's the idea, basically, that we provide the mappings for TDX, CCA, and also for SCOAN, which is not a part of this project. But the idea is that this part of mapping should be provided by the vendors. And then this part, starting from these generic or some simplified artifacts, simplified, let's say, mapping, the verification engineer will have an easier life verifying that, so that he can also understand, let's say, from SCX, how it's different in AMD and how it's different in IBM and so on, that one has, let's say, endorsement in this case maps to this and so on. So one can then compare and contrast. So this is the key idea of that. And unless someone has some question, I want to talk about a novelty of this work specifically, that in this category of architecture lead solutions, this is the very first work on the formal specification and analysis. There is no existing work. ARM has internally, and now it's also published, so they have some verification, but that is not targeting the attestation part. So the attestation, from attestation perspective, specifically in this group, it's the very first work. And from TDX perspective, we had a previous paper in IEEE Access, which is this demystifying attestation in Intel TDX via formal verification back in 2021. And the model that we have, even the simplified model that we have currently, we have included many things, including the certificate chain and the verifier steps, along with the initialization phase, as I said. So that specific paper was only verifying the attestation protocol, and here our goal was to cover all mechanisms of attestation, starting from provision up to the attestation protocol. So it adds initialization phase, and so there are some specific measurements in that work. We assume these measurements to be constant. And here in this work, we take them as variable. That is, the adversary can change the measurements, and we do not have a constant measurement assigned to a specific trust domain or trusted execution environment. So basically, from question. Okay. So basically, this leads to a complexity of around 376 times compared to state of the art, which is this verification work, which was our previous work. Which means that it has, this number is just to show that it contains a lot more details than the one which exists before. Right. So as I said, so we have, this will serve as, not specifically this TDX. I mean, we are focusing more on ARM CCA, and this will serve as the formal foundation for fine-grained reasoning for this part, the frameworks part, where we will integrate RA-TLS, which is with the Barkhausen Institute, TU Dresden, and with ARM.
Question?
Yes, please.
So the 376 times, what is that metric? Could you say a little bit more about that?
Yeah, sure. So we have in the verification, and I will also demonstrate this. So in verification, timing is one of the criteria, the verification time, like the time at which I start the verification and the time at which I end, or simply by a time command. I can analyze that how much time it took for the verification, and that gives a rough idea of the complexity of the model. If I have the same property, for example, let's say I fix the property and I want to analyze how much time the tool took for generating, for doing that proof. So this gives me a rough idea of how detailed my model is. Because it's automated tool. So if the property remains the same, I can compare, let's say, model A, which is our current model in this work, and the one which is the other work, which is this our previous work. So the ratio of the two, let's say, I think it takes around 3 minutes something for the current one, and for that it took like 0.5 seconds. And the ratio then becomes roughly this number.
Okay, so I mean, this is a good thing. You've got a more sophisticated model.
Yeah.
Great, thank you.
There are other criteria also, like I can internally, it does the horn clauses. I can also compare on the basis of the horn clauses, how much I had there and then how much I have now. So, but that makes it a bit technical. Then I need to explain what horn clauses are and so on. So I have this simplified rough estimate of the level of complexity of the two models. This is just to show that although the verification work already exists, but the novelty of this work is that this model is much more detailed, much more fine-grained as compared to that specific model.
Got it, thank you.
Yeah, sure. Okay, so
I have one question. So
sure.
I was quite new on this formal things a bit. Here is this formal verification considering the fact that the attestation logic, the target attester, plus the attestation protocol, plus the verification side. So, or it's just on the device side.
Okay, so let me try to recall what you said. So on the device side means the trusted execution environment, right?
Yes.
And
yes.
on the verifier side, and what else?
So verifier side, which is on the remote side, basically. So does this formal verification cover the remote side also?
Yeah, both. So basically, on one side we have the evidence generation. On one side we have, on the other side we have this verification part. So this model actually contains both. So we have the evidence generation for TDX and a verifier that we have in the formal model that takes care of the steps that the verifier should perform. And I can also probably show you one figure where we have the whole protocol which shows all the entities. By the end or with the demo, I think I will show you that specific figure that will show all entities. It's not simply two entities like inside the Intel's mechanism. There is local attestation. So there is quoting enclave, provisioning certification enclave, trust domain, TDX module. What else? So there is the CPU hardware. So there are like 6 entities within the attester. And on the other side, the verifier. So these are the entities that we took in this specific model.
Right. So that was exactly what I'm looking for. Yeah. Thank you very much.
Yeah, welcome. And just to, since you asked, just to compare with this, there was in this model, the previous work, we did not have the provisioning certification enclave. And this is what we added for taking care of the initialization phase. This is the new entity that we have in this model.
All right.
Otherwise, the entities are the same, but they are much more detailed.
Okay, great.
Right. So formal methods, basically they are mathematical techniques, and the purpose is to guarantee that a system model satisfies some specific requirements. And that can be represented like this, that the system satisfies a specific property. And in our case of this protocol verification, now we have the protocols, and in the protocol world, the system basically means the protocol in combination with the adversary satisfies this specific property. So this property could be now a security property, confidentiality, integrity, and so on. So these can be the type of properties. But before I go into the 3 things, so these are the 3 core things I need to define for system protocol. What are the adversary powers and what is the property that I want to verify, that completes the whole picture. So formal methods in general, I have a system. I create a abstract model out of this system, which will represent the interesting parts which I am interested in verifying for that specific model. And then I have also these requirements which I want this system to satisfy. I formalize them in a formal language as properties. And then I use formal tools in order to verify that the model satisfies this specific property. So this is the core idea of formal methods in general. And in specific to the protocol verification, this property will be a security property. This model will be a combination of the protocol and the adversary. And then the idea will be that, does this protocol in the presence of the adversary satisfy this security property or not? So that's what we want to prove basically. Okay, before I go to the properties, I will now describe the 3 properties, protocol and adversary. If you have any question, feel free to ask.
Real quick, as a time check, I know Simon and you had originally requested around 20 minutes. I don't know if Usama, if you feel like you could pace things to if 10 minutes more would be sufficient, and Simon, if you could take 15 minutes instead, if that works for you both.
I can speak quickly.
Yeah, I
Do you
can.
think that you'd be able to pace things to wrap up at about 10 minutes, Sama?
Yeah, I can do that.
Okay. All right, great. Thank you.
Okay, sure. So properties. Now we have this relying party, and we have this attester. So attester containing all the entities that I described, and relying party, or consider it a verifier. So if that's the scenario, and attestation, as you all know, so there is an attestation request from relying party to the attester, and attester generates an evidence, and that evidence, on the basis of that evidence, here happens the verification part, and then if it is verified, if it is trustworthy, it sends over some secrets. And the properties of interest in this case are confidentiality. That is, these secrets or sensitive data, which might be personal identifiable information, are kept secret, not available to the adversary. The integrity, which is of the data or the message, which in this case is of the evidence, that the evidence is not modified by the adversary. And then authentication, that a relying party can reliably establish that it is talking to a specific trusted execution environment or an attester. And freshness, so that the evidence is not replayed, or replay protection. So these are the four standard properties that make sense in case of attestation that we want to verify. And for doing that, and to check that the model is correct, so we have several sanity checks that several parts of the model are reachable and they have the desired properties.
So since one of the goals was to adhere to the RATS model as closely as possible, Dave did point out in the chat that this is kind of skipping over the verifier with the relying party, would not be processing evidence. They'd be processing attestation results. Does that affect anything here?
Not really. So it depends on the scenario. So it will be, I just wanted to have a small figure to represent this. When I said that we want to closely follow RATs, that was in the sense of that, for example, some things which were missing, we added that. From verification perspective, it could be any entity. It could be, here the assumption is that the relying party is having a verifier co-located.
Okay, so this is looking at it with the background check model from RATS, then I assume.
More precisely, I would say it would be verifying relying party model is, as we call it, that the verifier is embedded within the relying party. So the idea here was, in this specific case, was basically to verify the architecturally defined remote attestation. And that's specifically for attester without any added complexity. So the whole model that we have, we put it in as part of the this. Basically, we put it as part of the frameworks where we verified specifically SCOAN, which has where we have like 3 phases which describe how the relying party will verify the verifier, and how the verifier will then verify the attester. But for these, let's say the vendor solution specifically, so we assume that there is this relying party, let's say, has a verifier inside, or we only want to verify the internal architecturally defined remote attestation of these solutions.
Okay, I do want to make sure that assumption doesn't affect things too much, because I think it is, a fairly important distinction. I think in a lot of cases, the verifier will not be co-located. It could be, but it may not be under the control of the same entity as the relying party. So if at all possible in the models that we create, if we could avoid that assumption, I think it'd make it for a stronger output analysis.
Right. So I will basically think about this if it would make sense, because that's more of a part of this, I think, but I haven't thought much about this. I need to think.
Yeah, if at the level that you're modeling, it doesn't make a large difference, then having it be explicitly not an assumption, could make it more extendable for use in more situations. But anyway, we could probably move on, but just a bit of feedback there.
Right.
If I could just add, jump on there.
Sure.
I think it is important. One of the things we're trying to do here is work with a common vernacular. And that slide, if you could go back to the one you were just on, where it had the
for properties.
Yeah, that one right there. I suspect if the leftmost box, if you just change that to verifier,
yeah,
then we're closer to, I think, we're closer to the RATS architecture kind of terminology. I don't think the verifier is necessarily asking for the attestation request. Oh, it's getting after the evidence, I guess. So yeah,
actually the model, sorry to interrupt you. So in the model, actually, I hope you still see the screen for the code, and it's actually the verifier. So this entity specifically represents the verifier.
The one on the left that we were just talking about.
Yeah, for the sake of time, I wonder if we could just take this as a note to make sure that we don't allow that that assumption to creep in, and to make sure that those two roles are kept distinct.
Sure, that's right. Okay, so quickly about the model. So basically the model is incomplete. That's due to the end specifications by Intel. And the idea here is that why do we verify the incomplete model? And the core answer to this is that we need to integrate the for methods as soon as possible, because it's security critical mechanism. And we filled in some of the details based on our own knowledge of its previous version, which was TDX, with which it shares some of the things, and the decap protocol that it reuses. And we did some experiments to see like which keys are actually how long they persist and so on. For example, attestation key and so on, that we filled these details. And also based on the discussions with Intel, we had updated these details. And the details which are still missing are assumed to be secure. We provide no guarantees of these, because they are not verified. And once they are available, they can then be added to the model. And I want to clarify the goal here. The goal here was not to show the attacks, which is easy. When the model is underspecified, it's very easy to show attacks that, okay, so this thing is missing, so let's do it like this. And for example, it will then break the model. And the goal was actually to find a working model which works under as much possible flexibility as possible, but which is difficult and needs a deeper understanding of how the thing is actually built. Okay, threat model, adversary. So Delavio adversary, full control of the communication channel. Everything between the two entities that I showed is passed through the adversary. Party A sends data to the adversary, adversary forwards it to the party B, and so on from the other side. So it can modify data, drop all messages, and do all kind of things. As I said, the variable measurements is one of the possibilities that adversary can do. It can change the measurements, and then it's the verifier responsibility to take care of this. And from the adverse TDX specifically, we have adversary to take has full control to create fake TDs. TD is the name for the VM. So it can create these trust domains and get the code corresponding to that. And then the verifier will decide whether it's fake or not. And we explicitly define which channels are secure in the assumptions, which I will probably might have time to demo also. I will quickly describe some of the challenges that we had and then finish off, I think. The specifications of TDX are like 1,500 pages. Of course, we do not need each and every page for specifications, but somehow, because we have a lot of entities, some things are dependent on the other things, and somehow we need to understand a lot of these things. And it inherits specifications from SGX and SDM. The software development manual itself is 5,000 pages. The specifications are in natural language. We have to translate them to formal one. The specifications by Intel are ambiguous, incomplete, and contradicting. We have many examples in the draft. And one thing that I really want to describe about the Intel guys, like what's happening now is that the specifications are updated on the same link, like the white paper, it's updated on the same link. One cannot really have transparency on this. What was the previous version? What happened to that before? What was the previous version of that? For SGX, it was quite better that we had like each kind of update for that. And I would really like to say that this is really leading to an absence of transparency and leading to a lot of problems in the verification, that I cannot really go back to the version, find the version back that I was verifying. And I would like to ask Intel to stop this, because this is really very difficult when one cannot really check back what was the previous version which was actually verified. Okay, I think that
really quick, so I think this is an area that the SIG could have a place in to help influence industry in these types of areas. Is this a bit of something that could be taken perhaps as an action item to follow up on from our
this
folks
is
from
very
Intel?
interesting from my point of view, in that it's exactly the sort of interaction which I can have as an exec director. So look, this is our SIGs are having issues with this, and we'd like formally to ask for these changes not to be made, or for this approach to be taken. So I think it's worth noting this down and seeing whether this SIG wants to use me in that way.
That's a good question, Mike. So first of all, Selma, I appreciate the feedback. If you want to write that to me in an email, that will help me be like not ambiguous myself on what we mean by same link.
Mm-hmm. Okay, so by same link, I mean that the white paper, for example,
real quick, Osama, in the interest of time, I wonder if you could follow up on this offline.
Sure.
And Mike, I think this could be a good use here for you. I don't know, like once we settle down on the specifics, of course, your best judgment on what there is to follow up on, or if there's anything for you to do. But if the three of you, maybe Osama, Dan, and Mike, could sync up on this.
So I think this is something that we should put together, take to the TAC can then make a recommendation, but I think that would be certainly an option. I'm happy to work with Osama and Dan, of course. Thanks.
Okay. All right.
Yeah. Cool, thank you.
All right, so we are with 10 minutes remaining at this point. Do you have any final thoughts? And I guess Simon, are we cut you too short?
That's not my call. If the risk of rat holes, do you want to keep talking about this, because there seems to be a lot of interest, and then we'll defer, rather than me try and rattle through? I've only got like 6 slides, but rather than me rattle through.
All right. Well, let's go ahead. If you're available for the next meeting in 2 weeks, maybe we can bump you there.
I'm happy to do that rather than rush.
Okay. All right. Thank you so much, Simon. So Osama, that you have more time.
Okay. Thank you.
So you can back up to where you left off. Yeah.
Yeah. Let me try to find this. Okay. So. Right, I have some more challenges which are more technical, and probably I would ask if you guys would be interested in the demo rather than, I think I have a couple of slides more. Or maybe I can start the demo while it completes. We might have. So this is the model that we have currently, and that I will share in the repo today. And this will try to convert these into horn clauses and then do all the processing. So in the meantime, I will go back. I had a plan to describe these comments. So just I will quickly show that even if you are not familiar with the horn clauses and all these, let's say, these formalisms, even for systems engineer, this information is very useful, that we have this we have these set of assumptions on which this model is based. And the implementation has to absolutely follow these assumptions, otherwise the proofs do not hold. Then there are initialization steps. What happens starting from the generation of the keys up to the generation of the attestation key certificate. And then some attestation protocol steps, starting from the beginning, that the trust domain generates a key pair, up to the verifier, as somebody was asking. So the steps that the verifier will take for verification is here step number 19, final, and on the basis of which it will take a decision. I will also add a figure which better shows how this all is happening step by step. So the top part is basically the initialization phase. So this is all the entities which I previously described. The host VMM in this case is untrusted, denoted by red. The red denotes the private keys, blue denotes the public parts of the keys. And then the idea is that after this initialization phase, we have the attestation protocol phase, which is at the end doing the verification of this signature chain, freshness, measurements, and at the end, this is doing the asymmetric decryption of the key which was generated at the beginning. And I will put all of this material there. I want to quickly show the certificate chain, which probably I did in one of the SIG talks, starting from the root CA up to the trust domain. And this is what the verifier has to, starting with the root certificate. Assumption is that the verifier will have the root public part of this Intel's root key. And starting from that, it will start up to get up to the trust domain. And then how these structures are basically modeled. The structures that you see here, for instance, TD code and AK certificate are, so this is the TD code, and internally it is based on the TD report, which is doing the local attestation. And this is, so this one is basically of the TDX module, one of the entities there, and this is specifically for the trust domain TD. And then the hashes of both are stored within the generic MAC structure, which is then parts of this are transmitted. We optimize this, for example, that not everything here, that's also interesting, that not everything here needs to be transmitted to the verifier. For example, like these hashes are no longer required to be sent, which was Intel's initial proposal in their specifications, because the attestation key will actually sign this code body, and this will become, these claims will become a part of the code body that will be signed using the attestation key. So we do not need to send these hashes. So that came up when we asked Intel, like, what's the use of this, and how does it get the actual data with which it can compare the hash. So we have not only verified it, it has led to the optimization of the protocol itself. What exactly do we need in the code body? Okay. I think that's okay. So we have by now this result which says that the 3 of the queries are false, and we need to parse it a little. It says not of event is false, which means that basically it is reachable. This is these 3 are the 3 sanity checks that the parts of the protocol are reachable. So these are defined within the protocol. And this specific property is representing the integrity property. That is when the code was verified at the verifier end, the TCPI claims that it had, the TDI claims, and the R data, which is the custom field, they match what was sent by the CPU TCPI claims, and the R data are integrity protected. And similar property for this, when the code was verified, the TDX module, which generated this TD report, which was one of the structures here. This one for TDX module, TCBI, the integrity of this specific structure is also protected. And finally, the secrecy property, which is that the final secret which it sent at the end of the protocol is also kept secret. It's not available to the attacker. So this is the overall idea of the verification. There are other properties which I have commented just to save time. And I will quickly go back to complete this in a couple of minutes only. So the comments in codes, so previously I described the problems with the specifications that Intel had. And next thing was that, okay, so let's explore the code to see or to fill the missing information. And then we found that the comments within the code were also inconsistent. These now the next challenges are more related to ProVerif. How do we model the adversary precisely within ProVerif? As I said, so the state of the art used constant measurements and very simplified models, and how to make the formal model as realistic as possible with the variable measurements as I described. And another challenge was that there are several user-defined inputs, for example, R data, which is dependent on the specific use case. And we wanted to have a coverage of all, and the minimal thing that needs to be done for that for these user-defined inputs to be secure, which will lead to the security of the protocol. I mean, we tell the user, let's say you have to put this public part of this TD key, and the adversary and the challenge from the adversary, or maybe it might be more precise if I show this. So we tell that let's say the R data field should contain at least this appended with whatever you want to send in addition to this. So these minimal requirements for the user inputs. And demo I have already done. So just a quick that just don't only test, also verify, and don't just believe, also argue. And what I mean here is that by discussion and arguments, we found many things which we initially in our previous model we believed to be true or believed to be secure. And then only by verification one can actually find the thing or the assumptions behind these things to be true. Okay, so this is the reference to our paper. I will share the slides, and you are very welcome to participate. I will in a few minutes upload everything that I showed to the repo that we have. And here's the link to the older SOK paper that we will update, and then that will be available. So great. That's all from my side. Thank you very much. And if you have any feedback, you are welcome to describe.
Great work so far, Osama. Dave had another comment in the chat. It looks like, like the diagram before, that the model was so far strictly between the attester and the verifier. And this is a huge step. But if maybe even as future work, having it extended to the relying party as well, to make sure that the guarantees can transfer with the tester being a separate role, or sorry, the verifier being a separate role, that I think would also be very helpful.
Sure.
Okay, so we are at the top of the hour. We didn't leave any time really for Q&A. If people could follow up with Osama offline or in the Slack channel, that would be great. For administrative stuff for next time, I think we need to pick a new chair for the next meeting. Any of the co-chairs available for that?
I can volunteer.
Great. Thank you, Greg.
Sure.
And also, a huge thank you for everyone who's filled out the survey. I have more than 20% more than I did before. Anyone else who hasn't done it, please do it. Thank you so much.
Okay. Thank you everyone for joining. It was a good status update, Osama, and see you next time.
Thank you. Thank you. Bye.
Everyone.
Yeah.
Thank you.
Thank
Bye-bye.
you. Take care.